Can we represent a linear equation in two variables graphically? Let's take a very simple equation and try to plot it on a graph. Something like x plus y equals 4. It is a linear equation as the maximum power of any variable is 1 and it has two variables x and y. Now how can this be represented on a graph? Let's have the coordinate plane on the right hand side. It's very easy to represent this equation graphically. All we need to do is find many pairs of x and y values that satisfy this equation. So let's make a table here that has x values in the first row and y values in the second. Now let's take three random values of x, say -1, 0 and 1. And with these x values, let's see what values we get for y. If x is -1, then y will be 5, because 4 minus -1 will give us 5. If x is 0, then y will be 4, and if x is 1, then y will be 3. Now we got three pairs of values which satisfy this equation. Now to get the graph of this equation, we just need to plot these points on the coordinate plane and join them. -1, 5 will lie here, 0, 4 will lie here, and 1, 3 can be plotted here. Now when we join these 3 points, we will get the graph of this linear equation. On joining these points, we get a straight line. This is the graph of the linear equation x plus y equals 4. It looks like a simple graph, but there are many things we can infer from it. First, the graph is a straight line. The graph of a linear equation in two variables will always be a straight line. No matter what linear equation you pick, its graph will always be a straight line. What else does this graph tell us? Another important thing it tells us is that whichever point you pick on this line, it will be a solution to this equation. Now these 3 points we surely know are the solutions of this linear equation. So let's take another random point. Say this one. It's 5, -1. When x is 5 and y is -1, we see that the equation is satisfied. 5 plus -1 is 4. So whichever point you take on this line, it will be a solution to this linear equation. And is there anything else you can deduce from this concept? Absolutely. If we pick a point which does not lie on the line, it will not be a solution to this equation. Take any random point which does not lie on this line. Say this point, -1, 2. It will not be one of the solutions of this equation as it does not lie on this line. And we can also verify it mathematically. -1 plus 2 is 1 and not 4. Now you know how to plot the graph of a linear equation in two variables. And apart from that, there are 3 main takeaways from this video. First, the graph of a linear equation will always be a straight line. Second, every point on the line will be the solution of the equation which represents the line. And third, every point which does not lie on the line will not be a solution of the linear equation which represents the line. What happens when we plot the graphs of a pair of linear equations in two variables? We see that next.